Okay, Matrix 101. Today we go through over Gauss-Jordan elimination or like Gauss-Jordan elimination. So as I understand, like this thing has two phases. So the first phase is called forward elimination. So it has two phases. First one is called forward elimination and the second phase is called backward substitution. One thing to keep in mind is this forward elimination works from left to right, and this backward substitution works right to left. Also forward elimination, like we consecutively move downwards, and in backward substitutions we kind of move upwards, if that makes sense. But yeah, we'll explain with an example. So for forward elimination, what we require is to identify pivots. So what we mean by pivots is the first element of every row. So this is pivot of this row, and every row the pivot will be right to the one above it. So this element is the pivot of first row, right? So then the for next row the pivot will be the one directly right to it below that row, right? So maybe there will be something here, but that won't be pivot. The pivot will be like this, so it will flow diagonally. So that is the pivot. So for forward elimination we need to make all the pivots to 1. So we need to make all the pivots to 1. We need to make all the elements that is below the pivot in the same column, like this one. So we found the pivot here, right? So all the elements below that pivot needs to be 0. All the elements below pivot needs to be 0, right? And what else? So for backward substitution, what we need, so for backward substitution what we need is, once we have the matrix in forward elimination form kind of situation, so that means like we have all the pivots in what we might call upper triangular form. So like all the elements below the pivots are 0, and diagonally all the pivots are 1, but there are some elements in the columns that are above it, right? So above pivot there is some values in there. So in backward substitution phase we need to eliminate these things. Basically we need to eliminate these things. So what we need to do is, from right to left we need to come from right to left. So in forward elimination we came from here, we started from the like top left corner, and for backward substitution we will start from the bottom right corner. We will start from here, and then first we will eliminate this, right? And then we'll eliminate this, then we'll eliminate this, like that, until it becomes like an identity matrix, right? So that is the thing. So first we need to go right to left, eliminate all the eliminate all the elements above pivot, right? So this is the algorithm part. Okay, so let's look at an example or something. Yeah, so suppose we have a set of linear equations, right? Let me take example. So let me take 1x plus 2y plus 3z equals to 14, and then we have 2x plus 5y plus 6z equals to 30, and then maybe 1x plus 2y, same thing, plus 3z equals to 12, right? So we have these three equations, right? So now we need to solve them, right? So first what we'll do, we'll make what is known as a augmented matrix form. So we'll write these equations in its augmented matrix form, right? So it will be like this. So basically we need to write all the coefficients of x, y, z, and also the answer, like the RHS part also separated by a line. So it will be something like this: 1 2 3, right? And then we have 2 5 6, then we have 1 minus 1 2 3, and then we have 14 30 12. So this is our augmented matrix, right? So we have our augmented matrix. Now we will try to do forward elimination. Yeah, forward elimination. So first phase, forward elimination. Let me write this again, or let's use the power of technology. Duplicate. Okay, so this is our augmented matrix. Then what we have to do here is, according to the algorithm, we need to make all the pivots to 1, right, and all the elements below pivots to be 0. Okay, so to make this, actually we can see that the first element from top left corner is already 1, so we don't have to do anything. In case we didn't have 1 here, then we would just swap the rows, right? Or we'll do some operations to make this first top left corner 1, right? So the first thing that we need to think about here is the second row, because the first row is kind of sorted right now, right? So but second row, if you see, so in second row we have this 2 and minus 1 that we need to get rid of. So for first row we have got the pivot, but now we need to cancel this 2 elements in the first column, right? So to do that, what we will do is we'll make some row operations like this. R2 equals to, we'll do R2 minus 2R1, right? So with that, what we'll get is 1 2 3, and then because we did R2 minus 2R1, so 1 so this 2 minus 2R1 is basically 0, so this will be like this 0. And also if you see the second, what is happening in the second column is because we subtracted 2R1 and it was 2 here, so it will be like 5 minus 4 for this column, and that will give us 1, right? Same thing in, if you see the third column, it will be 6 minus 2 into 3, so it will be 0. So it's actually so this example is really good, actually convenient example, if you can say. It's reducing our effort, so it will be like this, and rest as it is, like this, and this is fine. So we'll having minus 1, 2, 3, right? And because we did it in augmented form, right, so we need to do the same operations in our RHS part as well. So it will be like 14, and 30 minus 2 into 14, that is 28, subtracted from 30, it will be 2, and then this third row is as it is. So this will be the next form, right? And then we'll do another operations. So you can see like the like from the first row we have the pivot element, and below that pivot element we have cleared one element from here, but we still have another one to go, right? So we'll do that. So we'll do R3 plus 1, basically not plus 1 plus R1, R3 equals to R3 plus R1. So this will give us, okay, this will give us something like this: 1, 2, 3, 0, 1, 0. And because we did R3 plus R1, right, so this will give us 0 here, and 2 plus 2, it will give 4, and 3 plus 3, it will give us 6, and same thing here, so it will give us okay, so it will give us R3 over 12 for 26, so 14 to 26, right? Got it. So now you can see basically two of the rows are sorted. We have got pivot here, we have got pivot here, only a pivot left is to this one, right? Okay, we haven't solved the this situation here, because we have got pivot here, but we need to eliminate this 4 here, right? So we will do that just now. So basically this is like 4R2. Basically we need to subtract from R3, right? Subtract from, I was using equals to here, right? Okay, yeah, so let's use the same thing. So R3 will be R3 minus 4 R2, right? So this will give us 1, 2, 3, 0, 1, 0, right? 0, 0, 4R2. So 4R2 will be, okay, that was 0 anyway, so 6, and this will give us 18. So it will be 14, 2, 18, right? So now another one that we need to do is the last one. So this one we need to make to 1. So this you will have we'll have to do like divide by 6, right? That will give us, so that means it will be r3 equals to, basically it's just a scalar operation, so it will be r3 by 6. So we will divide the r3 by 6, so that will give us 1 2 3 0 1 0 0 0 1 and 10 2 3. Oh, awesome. Now the thing is, this that you are seeing here is called row echelon form. Row echelon form. So at the end of forward elimination phase, what remains is the row echelon form, right? So at the end of forward elimination, so we have done forward elimination for this matrix, nothing else to do, right? Forward elimination step is completed because we have all the pivots and all the elements below the pivots are 0. So we have completed forward elimination step, and at the end what remains is called row echelon form. So this is the row echelon form. So now, as part of Gauss-Jordan elimination procedure, we need to do further simplifications. So we need to do further simplifications, as in the sense we have to move forward to the second phase, that's called the backward substitution, right? So second phase backward substitution, correct? Okay, so the backward substitution tells us to do right to left and down to upward, right? So basically what we need to do is we need to clear out all the non-zero elements above the pivot, like above the pivots. So we first in forward elimination we cleared out below the pivots, now we'll do clear out above the pivots. So basically if you, and we will start from the right side, from bottom right corner. So first this one, right? So first this one will do. So if you look at this one, right, bottom right corner, we have the pivot, and above it, so we already have a 0, so we don't need to worry about this anymore. But in the first row we have 3, so we need to eliminate this 3, right? So we need to eliminate this 3. So if we want to eliminate 3, so what we can do is just multiply 3. We can just multiply the third row with 3 and subtract it from the first row, right? So we will do basically that only. So R1 will be R1 minus 3R3. So that will give us R1 minus 3R3. So that will give us, because all the rest of the elements are 0 only, so that will give us 1 2 0 0 1 0 0 0 1, and it applies to the RHS as well. So 14 minus 9, right? So it will be 5 5 2 3 So the so this is completed. This pivot is safe and secured now. Now this pivot, because like we have eliminated all the ones that are above it, and below it is, there is nothing below it basically. So now we'll move on to the next one. So it will be the, as right to left strategy applies. So we'll move on to next one. So here we have another element on top of it too, and we need to clear it. So basically what we'll do is R1 again, right? So we'll do an operation on R1. R1 equals to multiple of R2 basically. R1 minus 2R2. Yeah. So that will give us 1 0 0 0 1 0 0 0 1 and 1 2 3, right? So now the thing is, this that we have here is called reduced row echelon form. So this is called reduced row echelon form, right? Or RRF for short, and also in octave, right? So you can see that we have identity matrix here. So we have reduced it as much as we can, and also the RHS part of the augmented matrix, right? And this is now giving us the result, basically the solution. Now it is giving us the solution of the matrix, of the system of linear equation. So this would mean the solution to this problem is x equals to 1, y equals to 2, and z equals to 3. So this is basically Gauss-Jordan elimination method, and we have forward elimination, backward substitution, we have augmented matrix, and then we have row echelon form, and then we have reduced row echelon form. Okay, so yeah, I will end this one here.